All right, let's talk about your lab. So you got to the point where you timed the stoppers, and then you took off 4, you found the mass of all 24. So it says now find the mass of the washers by weighing all 24 and then dividing. So here you have your mass of your 24, and then mass of 1 will be this mass divided by 24. And then it says the weight of one washer. This does not mean in milligrams. It means change this grams reading to kilograms and multiply by 9.81. Fg equals mg. Okay, once you get the weight for 1, then it says record this value and use it to determine the centripetal force. So the centripetal force for each round will be this mg that you found, the mass of 1 times 9.81, times the number of washers you were using. So times 24, times 20, times 16, etc. And you get your centripetal force. Then it says, oh yeah, so hopefully you got this column. You had the time for 30 revolutions. Now divide by 30 to get the time for 1. And then it says calculate the speed for each trial using V equals 2 pi r over t. Okay, so here you're going to do 2 pi r over t, where r was your 50 centimeters. Make sure you change it to meters. Right, so you're going to do V equals 2 pi r, 50 meters, and your t is going to change. And you're going to get your speed here. And then you're going to square that speed and have your speed squared. Okay, that's your full chart completely done. So then it says plot it in a graph of f versus v squared. A graph f versus v squared. So on graph paper, a full page, I don't have either graph paper or a full page, but it wouldn't fit in the lens anyway. F is going to go here, v squared is going to go here. And you're going to plot your points, just like we've done a ton of times, okay? So you'll have 1, 2, 3, 6 points. It might be that not all of them will be perfect. I know that's hard to believe. But once you've plotted them all, then take a ruler and draw the best fit line through as many and as close to as many as you can, okay? Once you've done that, then question 1 says calculate the slope. So pick 2 points on the line, find the slope, y2 minus y1 over x2 minus x1. Then it says, what does the slope represent? So take a look at the graph and think, well, y equals mx plus b, and your graph should go through 0, so that'll be the plus b. What's on your y-axis? What's on your x-axis? So what must the m be? Okay, and of course, as you're doing this, think of the equation f equals mv squared over r. Okay, so you have your f, you have your v squared. Once you have figured that out, then showing it to me in number 2, then it says calculate the mass of the stopper using your slope. Now, the other piece that number 3 doesn't say, but I want you to do it, once you found the mass of your stopper, then I want you to do percentage error, because we weighed your stopper in the lab. Okay, so the one that we weighed will be your theoretical, the one you're going to find from your graph will be your experimental, and find out how good you were. Now, there are going to be some points up here that are off. For some of you, I would think it'll probably be the 4 and the 8 washers. But for others of you, it actually might be the 24 and the 20. Some of you said today that it was harder to do the heavier ones. So just be conscious that like a couple of them on one end or the other might be off, and then decide how much weight do you want to give those, like how accurate do you think those are. Okay, so again, take the mass of 24, divide it by 24 to get the mass of 1, multiply that mass of 1 by 9.81 to get the weight of 1. And then for the centripetal force, it's that weight of 1 times 24 times 20 times 16, etc. You take your time for 30 revolutions, divide it by 30, and then do V equals 2 pi r over t to get your speed, where r is 0.5 of a meter. Once you have that speed, square it. And then it's these 2 columns that you plot on your graph. F goes here, V squared goes here, Make sure you pick a nice spaced out interval so that you do not end up with all your points in one spot. Okay, use a whole page, use graph paper, draw the best fit line, find the slope of it, figure out what that slope is as you look at the equation of a line and the equation for centripetal force. Once you've figured that out, find the mass of the stopper and then do percentage error, using the theoretical value as the one we found on the scale today when we weighed the stopper right at the end, and your experimental as the one you got off the graph. Okay, we'll talk about sources of error the next day we are together, but everything else you should now be able to do. Okay, very good.